Hello everyone, today we are starting a new unit, and today we're going to start with talking about writing, graphing, and solving inequalities. So for this first video, we're just going to go over some of the vocabulary for this. So most of this should be a refresher, but we'll go ahead and go over it. So this first one, this symbol, this just means greater than. An example of that would be this graph here. So I see I have an open circle here, and I'm pointing to everything bigger than -1. And so the important thing to note here is that it's an open circle. And I'll explain that in a minute. But an example of that would be, for instance, x minus 2 is greater than -3. When I add the 2 to both sides, I get x is greater than -1, which is this graph here. So the point is at -1, my circle, and I'm pointing to everything bigger than it. And so we write this because this is representing all solutions to this inequality. So for instance, if I were to plug in, let's say, 5 into this inequality here, well, 5 minus 2 greater than -3. Well, when I do 5 minus 2, 3 is in fact greater than -3. And so that was what I put here, 5 greater than -1. That is true. Now the reason why we have an open circle is because I can have everything bigger than -1, but not equal to -1. So let's try putting -1 into this inequality here. So if I put -1 in for x, I have -1 minus 2 is greater than -3. Well, -1 minus 2, I get -3 is greater than -3. Well, that is not true. It's equal to -3, but it's not greater. So that is why we have the open circle. That is just saying I can have everything bigger than -1, but not equal to it. Okay, now this next one, I have the greater than symbol, but I also have a line underneath it. And what that means is greater than or equal to. Another way that we can say this that may show up in a word problem is at least. So like at least $500, saying it's going to be $500 or more. Or you can say no less than. Those all mean greater than or equal to. And so here we see I have a closed circle, and what that means is I can have everything bigger than 1 but also equal to 1. So an example would be 3x is greater than or equal to 3. When I solve for x there, I'm going to divide by 3, and I get x is greater than or equal to 1. So that's how I would write the inequality for this graph. And that's because of the closed circle. And so when I plug in 1 to here, since this 1 is greater than or equal to 1, that is true. And I can see that comes out to be true here. So if I put 1 in for x, well, 3 times 1, I get 3. And 3 is in fact greater than or equal to 3. And it's important there because I do have that line underneath, so I can have 3 equals 3 as part of my solution. And I see that is a solution here. Okay, and then this next one is less than. So again, when there's no line underneath it, that means I have an open circle. And so an example here would be 2x is less than 6. Well, when I divide by 2 on both sides, I get x is less than 3. And that would be the inequality that represents this graph here. And again, just talking about through solutions, that means that 2 is a solution, 2 is less than 3, 1 is less than 3, -2 is less than 3. But everything on this other side is not a solution, because if I plug in 4 for x, 4 is not less than 3. Okay, Okay, and then this last one is less than or equal to. So this one I can have everything less than that number or equal to it. Another way I can do this is at most. Or another way you may see this in word problems is no more than. And so I see a graph here. I have 2. It's a filled in circle because I can have everything equal to 2. And it's going to be x is less than or equal to 2. And so an example for this would be 4x is less than or equal to 8. Well, when I divide by 4 on both sides, I get x is less than or equal to 2. Oh, not 3, 2. Which I see in this graph here. So I have the circle at the 2, and I'm pointing to everything less than it. Okay, that's it for this video. You can go ahead and move on to the next one where we will be graphing.